When we evaluate a cargo ship, we almost always start with one number: capacity. How much does it hold? It feels obvious. More cargo equals better ship. For a long time, I stopped evaluating right there, and I was wrong. That logic only works when storage is scarce. When space is the limiting factor, capacity dominates design. So we build ships like vaults, one way in, one way out. Everything sealed inside a single controlled volume. It's simple, it's measurable, and it makes sense. But it assumes storage is the real bottleneck. And that assumption starts to break the moment traffic increases. Because once ships begin competing for dock time, something else becomes scarce. Storage isn't the first thing to fail, flow is. And when flow becomes the bottleneck, design has to change. But as traffic grows, the problem changes. In any transport system, more traffic shifts the bottleneck. Ports, airports, highways, they all slow down the same way. In space, it means too many ships, not enough docks. And once ships start waiting, time becomes scarce, not storage, minutes at dock. If one vessel takes twice as long to unload, every vessel behind it inherits that delay. Docks are slow to build, but traffic grows fast. Eventually, the constraint isn't how much a ship can carry, it's how quickly it can clear the dock. That's where the capacity mindset stops helping. Have I been ranking ships by the wrong variable? If so, what does a cargo ship look like when time is the variable that matters most? If storage is the main limit, cargo ships start to look the same. One primary access point, one large cargo hold. A controlled boundary between inside and outside. Loading becomes sequential. Simple geometry with few decisions and predictable loading. This is vault architecture. It prioritizes keeping everything contained and easy to manage. It's intuitive. It's forgiving. It performs well in low traffic systems where ships aren't competing for dock time. To make that concrete, we'll use Star Citizen as a walkable test bed. Take the RSI Hermes. From the outside, you can read the loading plan. For cargo, there's one way in. Inside, the hold functions as one controlled space. It's built for storage first. And under low traffic, that simplicity is its strength. It minimizes internal coordination. But once dock time becomes the constraint, its sequential nature starts to show its limits. If one cargo path governs the entire hold, unloading speed is limited by that single path. It works right up until two ships are waiting behind you. I realized I wasn't asking how fast a ship clears the dock. I was only asking how much it could carry. That changes the ship's layout. You add more than one loading point, you enable parallel loading. This is flow architecture. Instead of organizing space around storage depth, it organizes space around movement paths. Cargo can enter and exit from more than one direction at the same time. Back in the sandbox, the Starlancer Max hints at this shift. From the exterior, there's a rear ramp and side loading doors. Inside, the layout organizes space around movement paths rather than storage depth. It looks less like a vault and more like a transfer station. The complexity moves inside the ship. And that raises the next question. If this buys time at dock, what does it cost to run? Flow architecture reduces time at dock. It doesn't remove constraint, it moves it. More access points means more decisions. Routing, sequencing, coordination. A flow-based ship is different. Cargo can enter from more than one direction. Partial unloads are possible without clearing the entire hold. Parallel operations can occur simultaneously, but parallelism requires coordination. Which ramp handles which cargo? Which vector clears first? How do you prevent internal congestion? The delay moves from the dock into the ship. That's when I realized flow ships aren't complicated, they're optimized for a different bottleneck. In this case, the constraint lives inside the hull. It demands more planning, more discipline, more awareness of sequence. In low traffic systems, that cost may outweigh the benefit. In high traffic systems, the external time savings begins to dominate, and that is what decides which design makes more sense. So why take on this complexity? If dock time is the problem, the obvious fix is to build more. Expand the station. It's a fair answer. But rebuilding infrastructure takes coordination, planning, and time. Traffic can spike overnight. It's easier to change the ships than to rebuild the infrastructure. Traffic grows faster than available docks. The dock remains the slow part. So the question isn't how efficient a ship is in isolation, it's what happens when traffic grows faster than infrastructure. At what point does waiting become the bigger problem? Every transport system eventually hits a limit. When that limit shows up at the dock, design stops being neutral. Vault ships aren't flawed, but under sustained traffic, their clearance time becomes the constraint. And once clearance time dominates, capacity stops deciding the winner. Back in the sandbox, you can see early signs of this. The Starlancer Max isn't fully optimized for flow, but it adds more than one loading point. That only makes sense in a world where waiting is a real problem. I used to think layouts like that were unnecessary. Now I see what problem they're solving. So in the future, do vault ships disappear? Or do they simply stop being the default? As trade concentrates, routes converge, delays compound, clearance time starts deciding who moves next. At that point, storage-first ships stop setting the standard. The designs that scale are built around flow. When time becomes expensive, the most valuable cargo ship isn't the one that carries the most, it's the one that leaves first. Less vault, more airport. So here's the real question. At what scale does that shift happen? Is this only true at major hubs, or does clearance time eventually dominate everywhere traffic concentrates? That's the variable, and it's the one I'll be watching.